Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video, we'll be looking at checkpoint 6.20 from section 6.4, where they tell us to use the power series to solve for this differential equation, y double prime plus x squared y is equal to 0 with initial conditions. Y of 0 is a and y prime of 0 is equal to b. Essentially, we have an initial value problem, and they're telling us to use a series to solve for that. So to use a series to solve for that, we're going to assume that our solution y is going to be the sum as n goes from 0 to infinity of some constant times x to the n power. So that's power series around 0, our center point. All right, so one way to approach this is to take a look at the first few terms and see if we can find patterns. You can also approach this by using this by dealing with sums and index renumbering, etc. But instead of doing that, let's see if we can get it through with patterns. All right, we'll assume that our solution will look like an infinite series, which is going to be, without writing it in some notation, but adding it term by term, we have c sub 0 plus c sub 1 times x plus c sub 2 times x squared plus c sub 3 times x to the third. Now, this thing goes on forever, and it's kind of difficult to know when you should stop. But maybe putting the first 5 here would be a good start, and we'll see if we need some later on. We'll tack on more terms. Now we do need to take the derivative of this, and if we take the derivative of this, the derivative of a constant is 0, so we'll just have a c sub 1 constant now, plus the derivative of this is going to be 2c sub 2x. And then the derivative of the next term is going to be 3c sub 3x squared plus, and then 4c sub 4x to the third plus one more 5c sub 5x to the fourth. And then this thing goes on forever again. Let's get to the second derivative because we need to replace in our original differential equation the second derivative there. So the derivative of a constant c sub 1 is 0, and so the derivative of this next one is going to be 2c sub 2, just a constant. The derivative of this is going to be 2 times 3 is going to be 6, but I'm going to keep it as 2 times 3, c sub 3 times x. And the reason why I'm doing that is because I want to find some sort of pattern as I go along here. And as I do these patterns, it would be good to try to see where these patterns are coming from and how they will develop. So the next one is 3 times 4, c sub 4 x to the 1 less than 3 is second power. So that's the derivative there. And then 4 times 5, c sub 5 x to the third power. Now, if we're watching this develop like this without knowing the first derivative, the next term's first derivative, we can assume that the term that's going to follow is going to be 5 times 6, and then c sub 6 x to the 1 less power 4. So we can see that these derivatives can be obtained even if we didn't see the previous derivative. We can get to the second derivative by just looking at what this sequence is feeling like. In fact, we can find the general sequence for each of these terms. This first term is this c sub n x to the n. When I mean term, I mean the first function y. The derivative of y prime is going to be n times c sub n x to the n minus 1, and then the derivative coming after that is going to be n times n minus 1 c sub n x to the n minus 2. So the only thing that's slightly different here is I got these two numbers switched, the lesser number and then the one right after that. So the lesser number is 5, the one after that is 6, and then this matches the 6, or the n, and then the c sub n matches, and then there's 2 less in the power. So keeping track of where these numbers are coming from would be an important part in doing this. Okay, so now that we have the first and second derivatives, let's put all that into the original differential equation. We have y double prime. I'm going to pick up as much as I can here, just put this much into the first the derivative. So y double prime plus x squared y will equal to, this is y double prime right here. It's going to be 2c sub 2 plus 2 times 3c sub 3x plus 3 times 4c sub 4x squared plus 4 times 5c sub 5x to the third. Let's do one more. 5 times 6c sub 6x to the fourth power. And then I'll put the dot 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 here. Remember, the dot 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 makes it legal for you to write an equal sign. Otherwise it would just be an approximation. And then we're going to add on x squared times y, and the y is the original c sub 0 plus c sub 1x plus c sub 2x squared plus c sub 3x to the third plus c sub 4x to the fourth. Maybe I'll stop here because we kind of know the pattern. Now we're going to distribute this x squared throughout, technically distributing it infinitely, but it'll look like this: c sub 0 x squared plus c sub 1 x to the third plus c sub 2 x to the fourth plus c sub 3 x to the fifth. Let's do one more: c sub 4 x to the sixth power, and dot dot dot. Okay. Now, between these terms, or between this polynomial and this polynomial, infinite polynomials, I want to combine like terms. All right, so the first two terms here are the constant term, 2c sub 2, and the linear term, 2 times 3c sub 3 times x. And so once I get those two terms out of the way, I can now begin matching up like terms. So I see the quadratic term here, the term with an x squared. I'll put those two together. I'll have 3 times 4c sub 4, and then I'll add a plus c sub 0, and then all that is going to be multiplied by x squared, so I'll pretend to factor out an x squared. Now the third power term, there's two of them here. I'll put those two together as well. So that's 4 times 5c sub 5 plus c sub 1, and these are being multiplied by x cubed. Okay, I see one more here. That's 5 times 6c sub 6 x to the fourth plus, whoops, the x to the fourth term is here, and so that's c sub 2, x to the fourth. And then so I can imagine what comes next here, right? Without seeing it, at least not seeing this term. So I would imagine this is going to be a 6 times 7 c sub 7 x to the 7 minus 2 is 5. And then the fifth term is here, c sub 3. And so that gets matched up with an x to the fifth power. Okay, so I'm going to put dot 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 here as well, plus dot dot dot, because technically it goes on forever. Now remember that the original differential equation was set equal to 0, so this whole thing is set equal to 0. And when you have an infinite polynomial set equal to 0, you will let each of these terms equal to 0 and then solve for that. As we do that, we hope to find a pattern, And that pattern is what will help us establish our relationship. Let's start with a constant term. 2C2 equal to 0. That would imply that C2 is equal to 0. Okay, so that's done. We have 2 times 3 C sub 3 is set equal to 0. So that would imply that C sub 3 is equal to 0. So that is also done. Okay. All right, so that's the first two. Let me see if I can rearrange this to save us a little bit of space. Now we look at the quadratic term. And this is the quadratic term. We have 3 times 4 C sub 4 plus C sub 0 is equal to 0. That would give us, if I solve for C sub 4 will equal to, let's bring the C sub 0 over to the other side with a negative, and let's divide out by 1 over 3 times 4. So this is going to be C sub 0 with a negative divided by 1 over 3 times 4. And that's C sub 4. Let's see, C sub 5 comes from the x cubed term. That's 4 times 5, C sub 5 plus C sub 1 equal to 0. So if we do the same thing, we get C sub 5 is equal to, let's bring the negative C sub 1 over to the other side, and let's divide out by 4 times 5. So it looks like C sub 4 is in terms of C sub 0, and C sub 5 is in terms of C sub 1. Okay, let's keep going. Let's do this one. We have 5 times 6 C sub 6 x, oops, the x to the fourth was factored out already, so was the x to the fifth. So let me cross this out and fix that typo, because we factored out the x to the fourth and x to the fifth in these things. Sorry. Okay, so now let's go back to 5 times 6 C sub 6. And I wrote this down incorrectly, so let's take away the x. So it's 5 times 6 times C sub 6 plus C sub 2 is equal to 0. And if we do the solving like we did before, we're going to get C sub 6 is equal to negative, and then this is C sub 2, 1 over 5 times 6. So now I can refer back, because I know C sub 1 and C sub 2, or C sub 0 and C sub 1 are just constants, and I don't know what they are. But C sub 2 and C sub 3 are equal to 0, so this whole thing is equal to 0. So that means C sub 6 is equal to 0. That's great. And the next term over here is 6 times 7 C sub 7 plus C sub 3 is equal to 0. If I solve for C sub 7 here, this will give me something with a C sub 3 in it. That's negative 1 divided by 6 times 7. But C sub 3 is equal to 0, so C sub 7 must also equal to 0. Okay. Now, I don't know the next, I don't have the next term here, but I know I should know what it is, right? Because if I follow the pattern, I'm looking at C sub 8 and C sub 4 relationship, right? Because these numbers just go up by 1. C sub 4 and 0, C sub 5 and 1, C sub 6 and 2, C sub 7 and 3. So I'm going to have something with a C sub 8. So it's going to be 7 times 8 times C sub 8 plus, and then C sub 4 is going to equal to 0. So that's my next term. If I solve for this, I'll get C sub 8 is equal to negative 1 over 7 times 8 times C sub 4. And I have C sub 4. C sub 4 is right here. So if I replace that, C sub 8 will become negative 1 over 7 times 8. C sub 4 is negative 1 over 3 times 4 times C sub 0. All right, so let's just summarize this a little bit. This would be c sub 8 is going to be positive now. This is a negative negative, and so this will be a fraction 1 over 3 times 4. There's no 5, there's no 6, but there's a 7 times 8, c sub 0. Okay, so that's c sub 8. And then let's do one more. The relationship with the c sub 9 is going to be 8 times 9, c sub 9, plus, and I'm looking at the one right before, that's c sub 4, so this must be c sub 5. And this is equal to 0, so if I solve for c sub 9, this will give me negative 1 over 8 times 9 times c sub 5. The c sub 5 being negative when we brought this over to the other side, and then we divide out by 8 times 9. All right, but c sub 5 is actually equal to this thing, so c sub 9 is actually equal to negative 1 over 8 times 9 times negative 1 over 4 times 5 c sub 1. Not that it matters, but I could have put the c sub 1 inside the parentheses. Maybe that would be a little bit clearer that that's what we're replacing, c sub 5. So c sub 9 is actually equal to negative, and a negative is a positive, 1 divided by, now we have 4 times 5, there's no 6, there's no 7, we have 8 times 9, and then c sub 1. Okay. You'd probably guess that c sub 10 and c sub 11 would be equal to 0, because then it would be related back to c2 and c3. And then c sub 11, c sub 12, and 13 would be following this pattern as well. All right. So if we look at our original, what we said our solution was, we said that y is equal to c sub 0 plus c sub 1 x plus c sub 2 x squared plus c sub 3 x to the third plus c sub 4 x to the fifth. We went all the way up to c sub 9. Maybe we'll write that out. I'm sorry, I lost track of the powers here. This should be c sub 4 times x to the fourth plus c sub 5 x to the fifth plus c sub 6. Oops. C sub 6 x to the 6th plus c sub 7 x to the 7th plus c sub 8 x to the 8th plus c sub 9 x to the 9th plus dot dot dot. All right, now if we actually put in our values, we put in our values, well, we can actually, I think at this point we can try to figure out what our, we can actually use our initial conditions already. Y of 0 is equal to A and y prime of 0 is equal to B. So if we put in 0 for x, I'm going to get the constant c sub 0, and then I take all these derivatives, well, all these terms, c sub 1 times 0 plus c sub 2 times 0 squared. Clearly, all these terms will have zeros in it. So this will just be equal to 0, which means y of 0 is equal to A, and this will just mean that c sub 0 has to equal to A. And that's good because we have a bunch of terms that have c sub 0 in it. At least we're only seeing a couple of terms here. On the other hand, if we put the derivative, if you remember from up there, the work that we did is going to be c sub 1 is the only constant. And then we have 2 c sub 2x plus, and all kinds of other terms with an x in it. And so if we put 0 in there, 0 for x and 0 for everything else in here, I will make that disappear. So c sub 1 is going to equal to our y prime of 0, which is equal to b. Okay. So now that we've solved for those values, we can put it into our equation. So thinking back about our equation here. Y is going to equal a c sub 0 plus c sub 1 x. Now we got 0 for c sub 2, right? So maybe we'll write 0 here. We got 0 for c sub 3, but for c sub 4, we got that to be minus 1 over 3 times 4 c sub 0. So the next term is going to be minus 1 over 3 times 4 c sub 0. And then that is multiplied c sub 4. This is c sub 4. And that's multiplied by x to the 4th. Our x to the 5th term, c sub 5, is going to be another negative 1 over, and that's 4 times 5 c sub 1. 4 times 5 c sub 1, and this is multiplying x to the 5th, because that's our c sub 5. Our c sub 6 term is 0, our c sub 7 term is 0. And now our c sub 8 term is positive 1 over 3 times 4 times 7 times 8 c sub 0. And this is 5, 6, 7. This is the 8th term, c sub 8. So this is x to the 8th. And then we have x to the 9th down here, plus 1 over 4 times 5 times 8 times 9, c sub 1, x to the 9th. And then I'll put dot, dot, dot with a plus. So let's replace the c sub a, or c sub 0 is equal to a. And in fact, let's factor them out. So these are the terms with the c sub 0, which is equal to a. So c sub 0 equals a. Factor that out, I'm going to get 1. I'm going to get minus 1 over 3 times 4, x to the 4th. And I'm going to get positive 1 over 3 times 4 times 7 times 8 times x to the 8th. So I factored out a c sub 0, which is actually a, and I'll put dot, dot, dot here. So all those terms are those terms of the c sub 0. And now let's capture all the terms of the c sub 1. And I'm just going to write the 3 terms that we have here. But, you know, they go on forever. So c sub 1 is actually equal to b, which we found up here. So if we factor that out, I'm just going to get an x for the first term. I'm going to get a minus 1 over 4 times 5 x to the 5th for my second term, well, my x to the 5th term. And then I will get a positive 1 over 4 times 5 times 8 times 9, and then multiply that by x to the 9th. Okay, so those are my 2 functions here. Now that we have the pattern, we should be able to tell what comes up next here, just for a guessing game. Should we be able to tell what comes up here? We have x to the 0, x to the 4th, x to the 8th, so you would guess that this term would be x to the, just add 4 to that, and so it would be x to the 12th. And then this would be a negative, because this alternates from a positive to a negative to a positive to a negative. And then this would be 1 over, we're going to have 3 times 4, we're going to skip 5 and 6, we're going to have 7 times 8, we're going to skip 9 and 10, we're going to have 11 times 12. And you see that that last number matches with a power of x. So that can go next. You should be able to tell that that goes next. And then over here, if you're looking at that pattern as well, this should be x, and then you add 4, you get x to the 5th. You add 4, you get x to the 9th. If you add 4 to that, you're going to get x to the 13th power. This will also be a negative, because this alternates from positive to negative, positive, so the next term would be negative. And then your fraction here will be 1 over, we have a 4 times 5, we skipped a 6 and a 7, we have 8 times 9. We're going to skip 10 and 11. We're going to have 13 or 12 and 13. And just like what we had before, that last number here matches with the power of x. So we could figure out more terms if needed, but I think at this point this is what we're looking for. All right, that was a long one. I hope that helps. Good luck.